Okay. So dividing by a negative number, we change the direction. So we'd get y equals 1/3 x minus 2. And now that we have this, we're going to graph. The test will be multiple choice. So for this style of question, you'd just be choosing the graph. So here is our graph. The y-intercept is at -2. And then the slope is 1/3. So we're going to go up 1 over 1, 2, 3, up 1, 1, 2, 3, like that. And then remember, if it has a line under it, it's a solid line. If the inequality doesn't have a line, then it's a dotted line. So because ours does have a line, it's a solid line.
For the equation, it's like at the very bottom of the work, it says y is greater than or equal to 1/3.
1/3 x.
Okay.
So there's the line, and y is greater than or equal to that, so we'd shade above. Y is greater than, so we shade above. Okay. And that's it. So I don't know if you remember back to semester 1, but there was some more challenging questions where we had like 3 of these inequalities and we found like this very specific little triangle in the middle. I didn't include any of that. It's like I kept it really simple. Okay, then for the next set of questions, it says solve each system of equations. So with system of equations, there's essentially 2 lines. You're looking at where they intersect to find the point where they intersect, and that's the solution. Actually, we'll skip these 2 and just go to the one where we're graphing to kind of get the concept, and then we'll do these 2 up here. So I'm skipping down to 16. Solve each system by graphing. In order to graph these, we need to have them in a y equals mx plus b format. So I'm going to rearrange these to get them in that format. Oh, it's blurry. For this one, same thing. So there's our 2 lines that we're going to graph and see where they intersect. And then wherever they intersect, that is the solution. So let's see. Making my coordinate plane. Okay, so for the purple one, the y-intercept is at 2, and then the slope is -1/2, so that's down 1 over 2, down 1 over 2. Cool. Then for the green, y-intercept is at -1/3. That's kind of annoying, but all right. Right there. And then the slope is 2/3, so up 2 over 3. About here-ish. put it right there, I guess. And when you go to connect them, you realize they do intersect at a pretty specific point right here, and that's at 2, 1.
Why are we not doing 14:15 a.m.?
We're going to go back to it. Okay. So we just graph the two lines to find their point of where they intersect, and then that is the solution. So one way to solve these would be by graphing. This one says specifically graphing. Again, it's multiple choice, so you'd be choosing the graph where these two lines intersect at this point. So the other way to do it would be through elimination. We're going to use elimination for these. So that's where we multiplied one of these by a number, so that way something would cancel. So for 14, 3y and 6y, I notice I can multiply all this by -2, and then the y's will cancel. So we're going to multiply all this by -2 to get -16x minus 6y, 10. Then this one's just going to stay as is. If anybody's taking the PERT or SAT soon, I feel like this is a really good review too. Okay, so at this point, we're going to add these up. We're hoping that something cancels. Well, we made it so something would cancel. The y's will cancel. We're left with -6x equals -3. X equals 1/2. So that is one of the coordinates. Now we have to determine what the y coordinate is. So what we're going to do is, now that we know that x is 1/2, we're just going to plug this into one of these equations. It doesn't matter which one. I'm just going to use that first one. 8 times 1/2 plus 3y equals -5. And I'm just going to solve this for y. Number 15, same idea. We're going to multiply one of these by something so that something would cancel out. Something that stands out to me is this 1/3 and 3. Now 1/3 times 3 would be 1. 1/3 times 9 would be 3. So we're going to multiply all this by -9. Our original, I'll just put off to the side. So we have our original right here, the first one. And then multiplying all these numbers by -9 would be -3x. -9 times -4/9 would be -4y. And then -9 times 4/3, you could write that out. Let's see, -9 times 4/3, you could do it like this. -36/3 is -12. Oh, this should be positive 4y, by the way. Some of you may notice that that is the exact same thing. Like if you were to multiply all this by a -1, it would be the exact same equation as this. If you add these all up, you'll get 0 plus 0 equals 0. So in this case, it's the same line, and they have infinitely, I don't know how to spell infinitely, many solutions for all real numbers. believe the answer key says this, so. The other thing that could happen, so you could either get numbers like this and it just solves normally. You could get this situation where it's just like 0 equals 0 or 3 equals 3. Infinitely many solutions. The other scenario would be if you get an answer like, use a different color. If you get an answer like 2 equals 3, which 2 doesn't equal 3, that would be no solution. And that would happen if the lines were like parallel, because it would never intersect. Next. Okay, so now we're moving into exponents. It says express this using positive exponents. Okay, so when you have this situation where you have the same base, n and n, and this is multiplied, you actually add these exponents. So this would be n to the negative 5th power. But it says express using positive exponents. So n to the 5th power would be 1 over n to the 5th power, like this. Okay, for the next one, we have this situation here. We're going to put the square on each individual number. So this would be 6 squared. And then you multiply these exponents here. So this would be t to the 10th power. So our answer, 6 squared would be 36. 36 t to the 10th power is the answer. Okay, next. Ready? Next page. Okay. Simplify this expression. Okay, well, even though they have these parentheses, it's all multiplication, so you could just envision all of these kind of separate. And then combined things are kind of in common. So 4 and negative 2, 4 times negative 2 would be negative 8. G to the 3rd power times g to the 5th power. You'd add those exponents to get g to the 8. I know it can be kind of hard to remember whether you add or multiply those exponents, but if you look at the concept, this would be g to the 3rd power, so that's g times g times g. And then you're multiplying by g to the 5th power, so that's 5 g's. And that would make a total of 8 g's. And then just h. There's one h here. And that's your answer. Okay, next, factor each polynomial if possible. If the polynomial cannot be factored, write prime. Hi, Andrew. Okay, so k squared minus 100. That would just be k plus 10, k minus 10. Like that. You may want to check it just to make sure it comes out to this original thing. So k times k would be k squared. Outside would be negative 10k plus 10k minus 100. Negative 10k and 10k would just cancel, so you get k squared minus 100. So therefore, you know that this is the correct answer. Okay, 21. Same idea. Problema. Okay, so something that stands out. I want to do this. Right? I don't know if that's what you saw in your head too. However, when you go to FOIL this out, you get 4x squared, which is great. Then you get 10x plus 10x plus 25. So that would be 20x in the middle. That is not part of this original. So what we did actually doesn't work. For this one, it's prime. Ooh, you remember that word? Nice. Good job. Yes, it's prime. You can't do that. You can't factor it. Okay. Next, Factor each polynomial. I started out with the easy one. This one doesn't have a coefficient in front of the h squared. We need two numbers that multiply to 27 and add to 12. And those numbers would be 9 and 3, right? 9 and 3 multiply to 27, add to 12. So that's what we use. H plus 9, h plus 3. You might even FOIL it out just to make sure it equals that same original. And it does. Cool. So that's how I did it on my end, and then I looked at the answer key, and that wasn't there. But what was there, that's the same thing, is h plus 3, h plus 9. So however it is, or whatever order, that is fine. Okay. Now we get into the more complicated ones. There was a method for solving these. However, before you use that method, you need to make sure that you can't factor out a common factor here. So I noticed that a factor that can be taken out of all these three terms is 2. So we're actually going to do that. We're going to take a 2 out of all three of these terms. 2 times b squared plus 5b plus 6. Okay, then at this point, need two numbers that multiply to 6 and add to 5. So 3 and 2. I was thinking 5 and 1, but that would be backwards. Okay, so 3 and 2 multiplies to 6, adds to 5. So this would look like this. 2b plus 3, b plus 2. Okay. So for the next two, I almost want to stop there.